Hi, my name is Vinayak Hegde. I work in testing, development testing, as senior QA engineer in the wireless networking group within Cisco. Today we are going to talk about some of the SP Wi-Fi features that we introduced, including new hardware in software release 7.3. Let's go and take a look one by one. What are those? The first and the foremost major scaled controller from the Windows side, we introduced a new controller, hardware appliance. It's named as a Cisco 8500 series wireless LAN controller. Let's take a look a little bit detail as to what features and then what are the scaled numbers this particular controller is supporting. This is just a look, the front-end look. This particular controller is mainly catered to the SP Wi-Fi world, where service providers are requiring large number of AP support as well as the clients. And also a lot of large campuses, universities, where there will be tens of thousands of clients to be serviced wirelessly. These are some of the feature overview or characteristics of the high-end controller. So if you see, the max number of APs it can support is about 6,000 and 64,000 wireless clients. Number of VLANs it can cater to is 4,096. It has two 10 gig interfaces connecting to the infra switch, and the number of Flex Connect groups it can support is about 2,000, and per Flex Connect group it can support up to 100 Flex Connect APs, and maximum number of AP groups is same as number of APs supported, which is 6,000. It can be used in variety ways of deployment model. It can support local mode APs, Flex Connect APs, and mesh mode APs. Max double LAN supported is 512, some similar to the rest of the wireless LAN controllers like the 5500 and WISUM2. Max number of interface groups 512, max interfaces per interface group is 64. So whichever the way a customer can use the combinations, permutations, and deploy it according to their need. It can support both indoor and outdoor mesh mode APs. Something that is in feature parity with 5500 and WISUM2. It supports both dual power supplies, whether they can be AC or DC. And continuing on that, on a redundancy level, for a single unit, the power supply can be operated in redundancy mode. It supports, as mentioned earlier, dual power supplies, either AC or DC. And also it has two 10 gig ports where you take wireless traffic from the wired side and switch towards the wireless side. So both ports can be backing up each other. A throughput so though you are using both the 10 gig ports, what it can support at the max is without data DTLS encryption is a 10 gig throughput it can support. With the data DTLS encryption, close to about 5 gig of the traffic. Another interesting thing that was introduced as a feature in 7.3 was high availability, box-to-box level high availability feature. So 8500 series controller paired up with its peer of the same capability can provide box level high availability with the APs. If one of the controller fails, the active controller that is servicing the wireless client, it can provide a seamless AP state machine transition. So that is a high availability stateful switchover for the AP in 7.3. It's going to be enhanced further for at the client level as well in the future release. Licensing scheme is, as you see over here, 300, 500, 1000, 3000 and 6000. And customer has an option of the add license scheme. You can buy the bundle and install the bundle with 100, 500, 1000. Continuing further, these are very key things. In the current 7.3 release, we do not support link aggregation. That means both the 10 gig ports cannot be bundled together. They have to operate independently. Guest anchor, 8500 cannot act as a guest anchor controller, but it can act as a foreign controller where you anchor the 8500, all the client coming in from 8500 anchored to either the 5500 controller or vice. It doesn't support TrustSec SXP as of this release. And WLC cannot act as an authenticator. That means internal local auth is not supported in this release. So as internal DHCP server, and it also does not support at this point in time wired guest. I mean, these are some of the features which were based on the feedback from the service provider world. They were not important to be implemented at this point in time. That was one of the reasons. Here's just the front. I'm going to show all three views: front, rear, and inside view of the controller. Fairly simple. It is as explained earlier, it's the one new rack space it provides. So here's the important thing: the rear view. So if you see, the new thing about that introduced is we enable HA port. I was mentioning earlier about the high availability one-to-one pairing with the peer 8500 controller. This is the port to be used. And the rest of the ports are same as the 7500 controller. And these are the two 10 gig fiber ports. Look and feel is very similar, so we have kept it so that customer is familiar with the existing UI. So it's same with the 8500 controller as well. So here's a typical comparison of 8500 controller on the left hand side. If you see with the rest of the controllers which are already released up to now, the main differentiator with the 7500 and 8500 are the three things that are in pink. It supports local mode, flex connect mode, and mesh mode APs. Number of APs and clients similar. AP count range is also very similar. Both have the same ports. The differentiator here is the 7500 only supports APs in flex connect mode, locally switched wireless traffic. Means wireless traffic of the clients is switched directly from the AP on the infra. Whereas 8500 can support termination of CAPAP termination of the wireless client traffic through the CAPAP into the controller and egressing into the DSI, and a similar fashion the downstream. We also introduced something called right to use RTU license, the add-on license that recall. So that's a new licensing feature that we introduced for both the 7500 and 8500. For the 5500 and Wisdom 2, the existing CISL-based mechanism remains. 7500, other difference is 7500 is only supports AC power supply, whereas 8500 supports both AC and DC. These are some of the major features that goes with 8500 and with the 7.3 and with all controllers, right? So RTU is the only differentiator for 7500 and 8500. So as explained earlier, 5500 and Wisdom 2 use CISL. High availability. This is a major enhancement. A lot of customers were asking for this, so we did box level high availability. I think in some other presentation this was explained in detail. Another major feature that we tried to bring in, considering the SP Wi-Fi side of the world, we enabled a functionality on our controllers, Win2 controllers, something called mobile access gateway. I'll go in a little bit more detail how it got integrated with the 3GPP core, packet core network. This is another announcement with 11U based Hotspot 2.0. It's also called as Passpoint. Specifically, this feature is, as you all are aware, to data offload from 3G, 4G to the Wi-Fi. So I'll go in a little bit detail further down the slides. What is PMP6? So this is the 3GPP packet core integration with Wi-Fi, whereas our controller acts as mobile access gateway and local mobility anchor, which is ASR 1K and 5K of the Cisco series. So let's go take a typical look into the how a bird view of this solution works. On the left hand side, these are the devices. It could be the Wi-Fi clientless device, and these are 3GPP clients, right? And then you have trusted Wi-Fi, which is our Winbook controller, providing services to the PMP6 client, regular Wi-Fi clients, I mean to say, .11, and it basically establishes a GRE tunnel with the ASR 1K and 2K, which is 5K, which is a 3GPP packet core mobile packet core network. So then the rest of the things are 3G and 4G cellular, which are SSGN and HSGW. So this is the functionality. Mobile access gateway is what has been developed and released with 7.3 for Winbook controllers. It will be supported on the 55, YSM2 and 8500 series of controllers. 7500 is not supported, or 2500 controllers. They are not supported at this point in time. LMA functionality is outside Winbook's product, as I mentioned earlier, ASR 5K and ASR 1K. It will, our mobile access gateway, our controller acting as a mobile access gateway, can terminate on 10 different LMAs, depending on how the customer wants to configure and then terminate that. So the number of PMP6 clients. So don't go by the IPv6 here. The proxy mobile IPv6, the terminology. We actually, with this release, we still support IPv4 Wi-Fi clients termination onto the LMA. So we still do not support IPv6 clients termination on the over the PMP6 tunnel to the ASR 5K and 1K. So that's a standard V4 GRE tunnel that is between mobile access gateway, our controller, and LMA. Let me also explain some of the other Wi-Fi features that we released along with software release 7.3. We introduced PPPoE client at AP. That means AP can act as a PPPoE client, and then it'll avoid. Basically, this will help. I'll go in a little bit detail down the slide how this is going to solve some of the customers' problems. Also central DHCP for Flex Connect, NATPAD support at AP, which is all part of the PPPoE features. We do VLAN tagging for the Flex Connect AP locally switched. We do increase number of VLAN support on the controller to 4096 now. Also, we did some of the radius relay enhancement, so it can do NAS IP attribute and support per interface group. Another enhancement we did is for the controllers that are acting as DHCP proxy, we introduced option 82, wherein the circuit ID information can be relayed to the DHCP server for an appropriate written off vendor service attribute. Also introduced is MAC hot failover to .1x in case MAC hot, a particular client that is trying to associate to the controller did not pass through the MAC filter list, so it is automatically fall back to .1x mechanism, so that it is tracked. Wi-Fi Passpoint certified. This is the pre-hotspot 2.0, and it is also now supported to Flex Connect and mesh, that is RAP only, not the maps. A little bit detail about the PPPoE support in Flex Connect AP. So earlier, operator who is deploying PPPoE kind of solution, he need a branch router for where the client PPPoE session needs to get terminated. So that is avoided now. So AP in PPPoE submode, which is under Flex Connect mode, in PPPoE submode, it can direct the internet connection behind the FTTH network by adding AP acting as a PPPoE client, and thereby avoid branch routers. It is extended to Flex Connect AP in submode, and local switching behind the PPPoE requires certain configuration like NATPAD on the AP itself, and also it needs client IP management on the AP. So all these have been supported on the AP now. Typical architecture, how this is deployed. So in case of central terminated clients, you will see that lab will contact the PPPoE server and then terminate the PPPoE session, and then the rest of the traffic, client's traffic, central switching, it can talk to the 10.168.23 network. And then, for example, locally switching switched SSID, typically it is not going through the controller, but it is directly going to the PPPoE, and then it is subnet 192.168, which is local switch subnet. So that's pretty much about the PPPoE. Some of the caveats you have to remember is there's only one AP per branch is supported, and then all the features like central DHCP, DNS override, NATPAD are enabled by default at the AP level, even though those are disabled on the WLAN and cannot be disabled. That pad is run in software, so there's no hardware, everything is done in the software. No multicast support on the locally switched SSID. AP can run NetPad, but does not support local DHCP server. So it needs central DHCP. Although if you see the client is using central subnet, it is considered as a private network from external network. So for visibility from the external world, it is still considered as a private network. This is another announcement, major announcement based on the customer input. Number of VLAN interfaces, we now increase it to 4095. So there's a fair comparison prior to 7.3. What are those various numbers in terms of interfaces. So all of them have been increased. Number of interfaces, L2 M gates, L2 GARP multicasting M gates, L3 M gates, and RA M gates for IPv6. This is another announcement now for enhancing the current per WLAN radius source, supporting the interface group. So So this basically is what will happen is if you enable radius server is reachable from a dynamic interface, we now relay the radius packets from that particular interface. Earlier it used to be always from the management interface. DHCP option 82, so what we do with this is we added an additional AP name and SSID. Some of the service providers were asking for this. So based on the AP name and SSID, they know from where to what kind of options they can return to the AP. Sorry, for the client that's requesting the DHCP. So here's a flow how exactly MAC auth failover to .1x auth works. So let's say here is a static web user trying to come in. He's trying to associate to the controller, but his MAC entry is not in the list. So obviously he will fail. Now WLC will automatically put him into the .1x auth state. Then it will relate to the all the AAA mechanism happens. Once that is success, it will make the client associated. If that fails, then the client is put into the exclusion list if the feature is enabled. So this is another announcement for the Wi-Fi world. Last but not the least, the Wi-Fi Passpoint. What is it? Basically, it's a smart Wi-Fi hotspot. So where the smart devices, when the user walks into any hotspot, he's a 3G or a 4G user, but he walks into the Wi-Fi coverage area. So in advance, user will be advertised certain information, right? I think this was already there in the previous release, but the announcement went in standardized pre-hotspot 2.0. So like venue, service providers, various options and things like that, those are announced to the end user, the smart devices in advance, so that user can make a better choice whether to associate or take advantage of the service. So this is a typical flow of the various system components for the solution. This is where we come into the picture. WLC will act as a NAS client. AP is providing the wireless, and here is your handset that is 11U enabled, and ANQP takes care of various messaging mechanism when it will let client know what services are available over there. Some of the handset vendors, we already implemented 11U, Broadcom, Atheros, Texas Instruments, and some more in the pipeline. Some of the other chip vendors are supporting that too. So how does this work, the packet flow? What is the mechanism? A client comes in, walks into a hotspot area, and then he found an operator hotspot. So the reason is WLC is pre-configured with some of the 11U characteristics, and that WLAN is always sending those in the beacon, those information in the beacon. So 11U info is given to the handset checks that, and then using the ANQP mechanism, a two-way or a four-way handshake is taken place, and then from the AP, up till AP is 11 ANQP, and then it is encapsulated and sent to the ANQP server or NAS client, which is the WLC. Once client query, it is agreeing that yes, these are the services I'm looking for, it's matching, then client will go and say, handset has certain pre-entered checklist. Everything is meeting. Yes, I want to associate with that network. So association begins, and then the authentication starts. Mainly all .1x and then EPEX methods. Some of the useful information about the Hotspot 2.0. These are the beacons are broadcasted. Following information are available to the handsets, smart devices. When you group typical service provider kind of information that is given to the given over the air. So when you group, when you type various other things, and then once the handset, that is whether the Samsung, HTC Hero, or kind of any of the smart devices, they have the checklist pre-built, or they can customize it. They meet those checklists, one of these, or all of these, or some of these. They say, yeah, I think I'm ready to associate with this network. So once there is also a NQP query-based mechanism. So let's say in a checklist, client did get certain information, but it want to query the controller more and then get more information. He's requesting some more information. Please go ahead and provide me this. So some of those queries that is sent by the smart devices contain this, and then WLC provides that through the AP. Once client is satisfied that is meeting my requirement, his association, the .11 association, and then authentication, everything will begin from there. Some of the IE elements that we have for the operator section that's most commonly used are these, and Hotspot 2.0 IEs those are the 11U on the left hand side, and on the right hand side Hotspot 2.0 IEs for much more smarter Wi-Fi clients. And also, it's very important of some of the things, right? These in the bottom, there are two features that we already do. Proxy ARP service is most important because if there is a broadcast from the wired network and it is passed on over the air, there's a huge, wireless is a shared media, you lose a lot of bandwidth unnecessarily. So the controller does reply on behalf of the clients that is associated in run state. P2P block is basically you have two wireless clients associated passing traffic in the same double LAN. You don't want them in a public hotspot to be talking to each other, right? They should not be able to exchange information for certain security reasons. So the peer-to-peer block service, if it's enabled for a given double LAN, two clients on the same double LAN cannot talk to each other. Some of the operator identifiers in the beacon, interworking information element, venue info, network info, HESSID, and venue info describes hotspot venue that APs is installed, venue group, type, and name info, blah, blah, those things. This is typically what you see, various things for a smart device. That is, I think this is Samsung Galaxy possibly. So those are the information that are available to the client much before it can make a decision to associate to wireless network, the hotspot network. I think that's all I had at this presentation. Hopefully it was informational. Thank you very much.